Hello and welcome. Today we are going to be exploring how to find the area of a segment in a circle. To do this, let's recall how to find the area of a sector in a circle. If you remember, the area of a sector of a circle is equal to pi r squared times the measure of the central angle divided by 360. So in this case, we're going to have the area is equal to pi times 7 squared times 100 divided by 360. When I push this into a calculator, I find that the area is equal to 13.61 pi centimeters squared. And since it doesn't specify, I could leave my answer like this, but if I wanted to go one step further, I could multiply it out and get an area of 42.76 centimeters squared. Now let's go ahead and take a look at segments. A segment is the region bounded between a chord and the arc of the circle. To find the area of the segment, you must find the area of the sector formed by the radii and subtract the area of the triangle formed by the radius and the chord. So again, the area of the sector is going to be pi r squared times the measure of the central angle divided by 360, and the area of a triangle is 1/2 base times height. Looking at our first example, I am given a triangle with one side length of 6 and the height of 4. However, in order to find the area of that triangle, I need to know the length of the base of AB. I can use the Pythagorean theorem since I know that the height creates a right angle with that base. I can use the Pythagorean theorem to find the length of the segment AP. In order to do that, I'm going to take 4 squared plus b squared equals 6 squared. 4 squared is 16, plus my b squared is going to give me 36. So subtract 16 from both sides. Those cancel. B squared equals 20. Taking the square root of that, b is going to be about 4.8. So since this is 4.8, I know that's going to be reflected on this side of 4.8, which means that the total length of AB is going to be 9.6. So now let's go ahead and find the area of that segment. So to do that, again, I'm going to find the area of my sector, and I'm going to subtract the area of the triangle. So the area of the sector is going to be pi times my radius is 6 squared times the measure of my central angle, which should be 96 degrees. Over 360. So the area of that sector comes out to 30.144. And I'm going to subtract the area of my triangle, which is going to be 0.5 times 9.6 times 4, which comes out to 19.2. Subtracting 30.144 minus 19.2, I find that the area of my segment is 10.9. So let's look at one more example. This triangle, they've given me very little information about the triangle itself. However, I do have the measure of the central angle of 120 degrees, and I have the side or the radius of the circle of being 24. I know to find the height of my triangle, I drop a perpendicular bisector from the vertex C to the line AB, and that creates a right angle. Because this is a bisector, what it also does is it actually creates a bisector of this angle as well. So I know that that is now a 60-degree angle, meaning that this other angle here has to be 30 degrees. Using the fact that I have a 30, 60, 90 triangle, I know a couple of things about the ratio of those sides. So, given that my hypotenuse of this triangle is 24, I know that that's equal to 2x. So in order to find the length of the side x on the other side of the 60-degree angle, I'm going to divide that by 2. So I know that the side here is 12. And then I know that the other side length is going to be 12 times the square root of 3. And again, that gets reflected on this side. So I know that the length AB is equal to 12 times the square root of 3 plus 12 times the square root of 3, which is equal to 24 square root of 3. Now let's go ahead and start finding the areas. So again, the area of the sector minus the area of the triangle. The area of the sector in this case is going to be pi times my radius of 24 squared times the measure of my central angle, and I'm going to go back to that 120 over 360, and I'm going to subtract off the area of my triangle. So 0.5 times this 24 square root of 3 times the height is 12. So the area of the sector, when I push that in, gives me 602.88. And the area of my triangle is 249.42. When I make that subtraction, I find that the area of my segment is about 353.46. Thank you for watching our mini lesson on finding the area of the segment of a circle. If you are still having trouble, you may check out this website for some additional information and examples. Otherwise, please work on the assignment. Use the rules for special right triangles when applicable, or use Pythagorean theorem to find the missing side lengths. Thank you.